So, good morning, Year 10. Your lesson today is energy and efficiency. So, we have 4 starter questions here, all about kinetic energy. So, find your kinetic energy equation from last lesson and off you go. So here are your answers. So the equation you wanted was half times mass times velocity squared. If you got it wrong, it's probably because you didn't do your velocity squared first before you times it by the 0.5 and the mass. So what does efficient mean? Are you working efficiently? So have a chat with anyone else you can find in your house and then write a different definition for what efficient means. So efficiency is achieving maximum productivity with minimum wastage. So in terms of efficiency in energy resources, it is the amount of useful energy put out from a device or an appliance or piece of machinery. And the more energy output, the more efficient something is. So can you now just adjust and add to your own definition? You will notice as well that you can then actually split your energy into useful energy output and wasted energy. So when we look at energy, we must always equalize what goes in and what comes out. So the total energy in must equal the total energy out, regardless of whether that is useful energy or wasted energy. So in this example of the light bulb, you've got 60 joules of energy going in. 6 joules are used to obviously produce light. However, 54 joules of energy in this light bulb are actually used to heat the surroundings. Therefore, this particular light bulb is very, very inefficient. So again, I want you to add some information to your notes. So this wasted energy is called dissipated energy. So it's what has gone into the environment. So in the case of the light bulb, you've got 54 joules of dissipated energy. So here we have an example of energy dissipation in a car. So when your car is running, that fuel, that chemical energy of your petrol or diesel is transferred into kinetic energy in the engine and in your gears. The mechanical parts are going to get hotter, and some of that heat is transferred to the environment. It is dissipated. So that thermal energy from kinetic energy is wasted. It goes off into the environment and is not used to actually propel the car forward in the engine. So as always with physics, we have an equation for this to work out the efficiency of an appliance, a motor, an engine, whatever it is you're testing. So the efficiency of a device is equal to the useful output divided by the total input. And then if we want to turn this into a percentage, you need to times it by 100. So I want you to write down that equation there. Remember that no amount of energy can be, or energy transfer can be more than 100%. And machines will waste energy. So some of it will be lost, as we've said already, as wasted energy. So I want you to pause the video and I want you to note down 3 bullet points from this information. So here's your chance to have a quick go and work out the answer to this question. And here is your answer. Don't forget to include that it is a percentage. Here we have 2 exam questions taken from an AQA science paper. Pause the video and I want you to have a go at answering these questions in your books. See if you can understand how to do this. here's the answers. Obviously, if you haven't got them right, then go back to the question and just see where you went wrong. You may be wondering why the answer to the second question was 150%, and that's not allowed. So if you actually go back to the question, it says that this was an anomalous result. So in other words, this was a faulty answer, which is why obviously it's over 100%, which, as we know, you can't have over 100% of efficiency. So let's get thinking now. Let's think how we could increase the efficiency of a device. So why do devices waste energy, first of all? And then how could you possibly reduce that problem or that issue to make your piece of equipment more efficient? I want you to make a little table or two lists of why they'd waste energy and how you could make that better. Okay, so why would a device waste energy? It could be friction from the moving parts. It could be the resistance of a wire. So that covers our electricity GCSE topic. It could be air resistance, drag or friction. Or equally, it could be the sound created by machinery. So some cars or pieces of equipment, washing machine, for example, can be very noisy. Obviously, we don't turn a washing machine on to hear what it sounds like. So that is wasted energy. So how could we possibly reduce these problems? You could add some kind of oil or lubrication to the moving parts. That's why you need oil in an engine. You could use different wires. So in circuits, use wires with little electrical resistance. You could make something more streamlined, so that would reduce drag and air resistance. Or you could somehow tighten loose parts, joints, stop vibrations, and cut down on that sound, that noise wasted energy. So I want you to pause the video, and you can now add to both of your lists some more information of where energy is wasted and how you could reduce that problem. Okay, so now we've got a 6-marker question here. So we've got our angry bird here, and we want to know how you can improve the efficiency of this racing car. So you need to be describing those changes, and you need to explain how you could increase efficiency, make it better. So use keywords. We want to know what the energy transfers are. How is the energy dissipated? Why is it dissipated? And what is the useful and wasted energy involved? So 6-marker question, and then I want you to email me your answers. Thanks. Have a good day.